All right, so today we're going to look at systems of equations, story problems. And originally this was part of yesterday's lesson, but I broke it into 2 days just so we could concentrate on using elimination method yesterday and then on story problems today. So let's just read through the first story problem. Jennifer and Nicole are selling fruit for a school fundraiser. Customers can buy small boxes of tangerines and large boxes of tangerines. Jennifer sold 5 small boxes of tangerines and 7 large boxes of tangerines for a total of $102. Nicole sold 10 small boxes of tangerines and 5 large boxes of tangerines for a total of $105. Find the cost each of 1 small box of tangerines and 1 large box of tangerines. Okay, so if we go back through here and find important information, the first 2 sentences are just kind of setting the stage for us that they're selling tangerines to raise money for school. Then we get down here to where there's actually numbers. So Jennifer sold 5 small boxes of tangerines, 7 large boxes of tangerines for a total of $102. So that whole situation will end up being an equation when we get there. And then Nicole sold 10 small boxes of tangerines, 5 large boxes of tangerines for a total of $105. And then they want us to find the cost each of 1 small box of tangerines and 1 large box of tangerines. So when you get to that find statement or the question, depending on how they word it, that's where your variables are going to come in. So what we're looking for is how much does a small box cost? How much does a large box cost? So what variables do you want to use for the small box of tangerines and the large box of tangerines?
X and Y.
X and Y, that's fine. We can just do the generic. So say that X is the cost of a small box. I'm just going to put tang for tangerines. And then we'll say that Y is the cost for a large box of tangerines. And so that way when we get done, we can just keep track of what we actually solved for. So once we've established that, we can go back in and read this again. Jennifer sold 5 small boxes of tangerines. So let's just do that. 5 small boxes, since small boxes are X, would be 5X. And 7 large boxes of tangerines. So that would be plus 7Y, because Y is the cost of a large box. And the total is 102. So the word total kind of lets us know that's equals 102. So we're going to have a similar equation for the next sentence. Nicole sold 10 small boxes of tangerines. How do I write that? 10X. Very good. And then 5 large boxes of tangerines.
5Y.
5Y. Good.
Equals 105.
Good, equals 105. You guys are so smart. So there's our system of equations that we're trying to solve. So the elimination method that we were using yesterday, I like to call the kill method. We are going to try to set these up so we can either kill the x's or the y's and only deal with 1 at a time, because 2 is too much. So the easiest way to do that with these is to deal with the x's, because what I want to do is make those opposites. So 10x, I'm just going to leave, but I'm going to take this top equation times -2. And what that's going to do is it's going to give me negative 10x, that will cancel this one out here in a second. But I'm going to take -2 times the whole equation. You have to do the whole equation or it doesn't work. So -2 times 5x is negative 10x, -2 times 7y is minus 14y, and -2 times 102 is negative 204. And then the second equation, this time I can just leave as is. And what we're going to do seems strange, but we're going to add the 2 equations together. And so I have my x's lined up so I can combine them. We designed this so that I now have -10x and 10x, and we can kill them. There they're gone. And that just makes this easier to work with because now we will only have y's. So -14y and 5y, I go ahead and add together, gives me -9y. With the -204 plus 105, we get -99. And now I have a very simple one-step equation I can solve for y. So how do I solve for y there?
Divide by negative.
Good. Divide by -9, divide by -9. So we'll get y equals 11. So if we go back to the problem, that answers part of what they asked for. That is the cost of a large box of tangerines. So underneath that, I'm going to put it's $11 per large box of, and I'm going to abbreviate tangerines again. And I can box that, and that is part of what they're looking for. Now, we also want to know how much a small box of tangerines cost. So now that we know what y is, how can I find x?
So putting 11 in for y.
Yeah, put 11 in for y, and it doesn't matter which equation. So do you guys have a preference?
Bottom.
The bottom one? So I can take this bottom equation, 10x plus 5y equals 105, and I'll go ahead and do 10x plus 5 times 11, because I know that's 11, equals 105, and then we can solve that. So 5 times 11 is 55. The rest of the equation is still just what it was. And now we have a two-step equation that we need to solve. So what would I do first?
5 times, subtract 55.
Subtract 55. Good job. So subtract 55 from both sides, and we get 50 over here. Those are canceled. Got 10x on this side, and we just have to divide by 10. And we find out that x is 5. So what does that tell us?
$5 for a small box.
Yes, so we can just write $5 per small box tangerines. And I didn't do complete sentences, but I did a nice phrase that answers the question because it wants us to find the cost of the small box and the large box, so it'd be nice to know which one's which. It's possible they could charge you more for the small box. It happens sometimes. Crazy if you go to the store and you realize that, but all right, so that's elimination method. The only thing that we're adding to it today is assigning the variables and setting up the equations. The process, we're trying to get either the x's or the y's to be opposites so that we can drop them out. So let's go ahead and take a look at number 10. Shauna and Crystal each improvised their yards by planting rose bushes and ivy. They bought their supplies from the same store. And basically they're telling us that way we'll know that the prices will be the same regardless. Shauna spent $64 on 6 rose bushes and 10 pots of ivy. Crystal spent $100 on 12 rose bushes and 13 pots of ivy. What is the cost of 1 rose bush and the cost of 1 pot of ivy? So again, the first couple of sentences are just letting us know that they're buying roses and ivy and they went to the same store. It really starts giving us information down here. It tells us what Shauna spent and what she bought. It tells us what Crystal spent and what she bought. And then you get the question, what is the cost of 1 rose bush and the cost of 1 pot of ivy? So that's what we're going to be looking for. So we're looking for rose bushes and ivy. What do you want to use as variables?
X and Y.
Just x and y? It's kind of boring, but okay. So let's let x be the cost of a rose bush and y be the cost of a pot of ivy. See, I was thinking R and P, because then you just automatically know what they are. But if you wrote it down over here, it doesn't matter. You can use whatever. So then we'll go back and look at this. These are worded kind of backwards. It starts off with Shauna spent $64. That's sort of giving you the total on 6 rose bushes and 10 pots of ivy. So I like putting the 64 by itself on the other side. I would start here. 6 rose bushes is 6x. 10 pots of ivy is 10y. And then I like putting the 64 over here. Although you could do 64 equals and everything would still work. You just have your variables on the other side. You totally could. And then Crystal spent $100 on 12 rose bushes and 13 pots of ivy. So 12x plus 13y equals 100. So are there any questions on how we set that up, or is that pretty straightforward?
Pretty straightforward.
Makes sense. Okay, we did it last year. I'm just making sure. So what we want to do is we can multiply one or both equations by any number that we want, but we either want the x's to be opposites or the y to be opposites so that we can kill one of them. So what do you think would be easier?
X's.
The x's.
Top
What
by
could,
-2.
good, we could multiply the top by -2. It's not always -2, but that worked out on this one. And so that gives us negative 12x plus 20y equals, I'm sorry, that should be minus now because it's -2. I just erased the wrong thing because I can't see. Minus 20y equals negative 128. So just make sure you take -2 times each of them. I almost messed that up. 12x plus 13y equals 100. We can just leave alone. Sometimes you'll have to multiply both of them, but you're just trying to get it so that these are opposites, negative 12x and 12x, so that we can kill them. Here we go. Kill. There we go. There's my fun for the day. All right. So when we do that, we can add up what's left. Negative 20y and 13y. What's that going to give me?
-7.
Good. Negative 7y, negative 128, and positive 100
-28.
is negative 28. And now what do we do?
Divide by 7.
Okay, so divide by -7 because that's going to get rid of all of our negatives. And we get y equals 4. What does that tell us? What was y?
That's the cost of
Cost of a pot of ivy. So that means it is $4 per pot of ivy. Awesome. All right, so we found out the ivy. Now how do we find out how much the rose bushes cost?
Put that in.
Put it in. Can I put it in for whatever I want?
For Y.
For y. So you can use the top equation or the bottom, but you want to make sure you put it in for y. So which equation do we want to use?
Bottom.
The bottom one? That's fine. So we can do 12x plus 13 times 4 equals 100. 13 times 4 is that 52, I think? Yes. Sorry, I had to double check myself. So I have 12x plus 52 equals 100. So we're going to subtract the 52. 12x equals 48.
Divide by 12.
Good job. Divide by 12.
X equals 4.
X equals 4. So it is also $4 per rose bush. I always feel kind of gypped when you get down to the end and it's like, what was the same cost for both of them? But they didn't tell you that, so that might have made this a little bit easier problem if we had known that. All right, one more example. Number 11. The school that Dan goes to is selling tickets to the annual dance competition. On the first day of ticket sales, the school sold 8 adult tickets and 12 child tickets for a total of $168. I feel like this problem jumps to the numbers a little faster. I'm going to go ahead and underline that. The school took in $138 on the second day by selling 13 adult tickets and 6 child tickets. I'm just going to go ahead and get that all underlined. So I've got my first day and my second day information. And then what is the price each of 1 adult ticket and 1 child ticket? So that question, when you get to the question, those are the 2 things that are going to make up your variables. So are we going to use X and Y again?
No.
No. How about A for adult ticket and C for child ticket? So A would be the cost of an adult ticket, and C will be the cost of a child ticket. Just to make it different. So these are going to set up just like the others did. On the first day they had 8 adult tickets, so that'd be 8A. And 12 child tickets, so 12C, for a total of $168. The school took in $138, which would be my total over here on the second day by selling 13 adult tickets and 6 child tickets. What is the price each of 1 adult ticket and 1 child ticket?